So, most certification failures come down to one thing, and that's electromagnetic compatibility, or EMC for short. So, if your design radiates too much noise or is too susceptible to interference, it's going to fail EMC testing, whether you're doing FCC for the US, CE for Europe, or both. And a lot of that comes down to the PCB layout. For example, if you run long signal traces without a solid return path underneath the trace, like over a split ground plane, for instance, then those traces effectively become like antennas. High speed signals need a continuous ground reference to prevent radiating noise. And without that, they can leak emissions and fail radiated emissions test. Another common issue is ground plane fragmentation. If your ground plane is chopped up by vias or routing, then you end up breaking any low impedance return path, which again increases emissions. And then there's the power input filtering. If you skip ferrite beads, bulk capacitors, or LC filters on power inputs, you're inviting conducted emissions issues. Even power supply layout matters. A switching regulator with long loops or poor grounding can radiate across a wide frequency range and end up killing your EMC results. So don't just think about functionality, think about emissions and immunity, because the test lab will.